welcome to our 5th video lesson. This is 1-5, the distributive property, and remember to date your paper. So go ahead and get your title and the date, and as always your I can statement, what we hope we'll be able to do by the end of this lesson. Your I can statement is, I can use algebraic properties, and specifically for this section, the distributive. As always, to get our section started, we're going to begin with the vocab. And our very first vocabulary word is actually the title of our section, the distributive property. It states the distributive property, and you distribute the outside term to all terms inside parentheses by multiplication. And if you notice off to the far right side here, I left room for an example. So leave yourself a little bit of space to write a small example, even if it's just in the margin. So the distributive property, if I have something on the outside, so outside term, so I'm going to pick 3. And then I have a parenthesis and I have numbers inside there like 1 plus 2. What I do to show the distributive property is I have to multiply the outside term to everything inside. So I have to say 3 and then times 1. And I'm going to use parentheses to show the multiplication. So 3 times 1. I drop down my plus sign and I distribute again. 3 times 2. So 3 times 2. And if you notice up here inside the parentheses, I have 2 numbers. I have 1 and 2. Down here I have both these numbers being multiplied by 3. So that's how you distribute. Take your outside term, multiply it to everything inside the parentheses. 3 times 1, 3 times 2. Okay, this is as far as I'm going to take that one for now. So for our examples, we're given the directions to show distributive property and evaluate. So we must show the distributive property to evaluate these expressions. So for number 1, we get 8, and then inside parentheses 10 plus 4, and then close the parenthesis. Now, to distribute, we take our outside term of 8, and we distribute him in. And I call this showing the rainbow because where I make my arches into the parenthesis, it'll eventually look like a rainbow. So 8 times 10. Remember, I use a parenthesis here, so 8 times 10. Drop down my plus sign, and then show the rainbow again. 8 times 4. So 8 times 4. And if you look at the arches, it kind of looks like a rainbow now. All we have to do is multiply. 8 times 10, 80, plus 8 times 4, 32. Add them together, 80 plus 32 is 112. Box that guy in, we're good. Now number 2, we're given parenthesis 12 minus 3, close it off, and then 6. So it's a lot like number 1, but my number on the outside is on the right side. That's okay, we still do it the exact same way. We have a parenthesis, we have a term on the outside, so my term is 6, and I just distribute him in. So I always like to go to the farthest one on the left first. Go from left to right inside the parentheses. So 6 times 12. And then once again drop down my minus sign. And then 6 times 3. And right here, order does matter when you distribute, because if you notice that minus is in front of the 3, so that minus has to still stay in front of that 3. So then we just multiply. 6 times 12 is 72. Oh, sorry, 96. I was thinking 6 times something else. 6 times 12 is, nope, I was right, 72. Sorry about that. Minus 6 times 3 is 18. 72 minus 18 is 54. Okay. Now, the first 2 examples just dealt with numbers, so we had to evaluate fully to where they simplified all the way out to numbers. Now on the next two examples, we're going to have where they involve variables. So example 3 says 5 times g minus 9. So go ahead and write that one down. And we're going to distribute. So 5 times g, 5 times g. Drop down my minus symbol because he's in front of the 9, so he has to stay there. And then 5 times 9. Okay, then 5 times g, 5g. Minus 5 times 9 is 45. Now here's where we have to look. We have a term with the variable and a term without one. So I can't add these two together. I can't do 5g minus 45 because they're different. This one has a variable, this one does not. So this is simplest form right here because I have a term with the variable and a term without a variable. All right, the number 4, I have 3 and then parentheses 2x squared plus 4x minus 1. Okay, so I have 3 terms in this parenthesis, but I can still do it because once again, we're just going to distribute our outside term of 3 to everything inside. So instead of doing it twice, I'm going to distribute 3 times. So 3 times 2x squared. All right, drop down my plus sign. 3 times 4x. And then I'm going to drop down my minus symbol. And then my last rainbow is 3 times 1. 3 times 1. Okay? Now we multiply. And all we do is just multiply these numbers in front. Over here on this one, g didn't have anything in front of him, so I could just say 5 times g is 5g. This one does, so I'm going to have to say 3 times 2 is 6. And then my x squared just drops down. Plus, once again, multiply my numbers. So 3 times 4 is 12, and my x drops down. And drop down my minus, and then do 3 times 1 is 3. So you get to this last step, and you have to check to make sure it's in simplest form. These up here were easy because it was just numbers. This one over here was easy just because it had one variable and just a number. This one's a little bit different because we have terms with variables, and both variables are x's, but this x has an exponent of 2. This x doesn't have an exponent at all. So they're different. This one is x squared, this one's x, this one doesn't have anybody. So that is simplest form. That is as far as it can go. Okay, the last two examples deal with the like terms again, kind of like number 4. Well, we're just going to do this number. There we go. So examples are we're told this time to just simplify. And we're given 15x plus 18x. And we check them to see if we can add them together. We have an x here without an exponent. We have an x here without an exponent. So 15x plus 18x is going to give us 33x. Basically, the x just drops down. Nothing really happens to him. So 15x plus 18x just gives us 33x. He just drops down. Nothing happens to him. Okay? Then number 6, we're given 10n plus 3n squared plus 9n squared. So once again, we're looking for like terms. That means the same variable with the same exponent that we can add together. So I start first with my 10n. Does he have anybody else he can go with? Do I have any other just n's without any exponents? No. So he just drops down 10n. Now, I have a 3n squared plus, then I have a 9n squared. So they have both n's and both with the exponent of 2. If you notice, I underlined it twice to show where it had the exponents. And this one has exponent of 2, so I underlined him twice. So kind of the same way I did up there. As I multiplied the big numbers together, here I'm just going to add the big numbers. So I'm going to do 3 plus 9. So just add the coefficients. So drop down my plus sign. 3n squared plus 9n squared gives us 12n squared. We box him in because that's simplest form. This has n squared, this one just has n, so they're different, so I can't add them together. That's as far as we can go. Now, if you still have any questions about like terms and combining like terms like on 5 or 6, or if you have questions about distributing like the ones on the examples 1 through 4, please go back, rewatch them, replay them. Remember, first thing tomorrow we'll answer any questions we have. And please be sure you're ready to go. Thanks.